4. So here we have another rational function. It looks very similar to the last one, except that we have a few more factors in the numerator. So let's locate our wholes, vertical asymptotes, horizontal or slant asymptote, x-intercepts and y-intercepts. At this moment, if you would, please pause the video and work on finding each one of these. And then once you have them, hit play. All right, so we're ready to find our wholes. We're looking at our rational. We see we have no common factors, so we have none for this example. For the vertical asymptotes, that's going to be where our denominator goes to 0. So we have two places where that occurs. That's when x is equal to 1 and when x is equal to -2. So we'll document those. And then we have our slant asymptote. So for our slant asymptote, or horizontal asymptote, we need to compare the degree of our numerator and our denominator. So the degree of my numerator is 3, the degree of my denominator is 2, and in this situation, my top degree is bigger than the bottom. So we do not have a slant asymptote, we do not have a horizontal, we have a slant asymptote in this situation. So what we have to do is we need to perform long division and determine what our quotient is, because whatever the quotient is, that's going to be the equation for our slant asymptote. All right, so we're going to have to do some multiplication before we can do some division. So we need to multiply out our numerator. So we have x times, and let's go ahead and FOIL out this binomials here. So we have x squared minus 3x plus x, that's minus 2x, and we have minus 3, so that gives us x cubed minus 2x squared minus 3x. For our denominator, we FOIL this out, that's going to give us x squared plus 2x minus 1x, that's plus x minus 2. So now we're ready for our long division. So we are going to divide like so. All right, so we're going to look to see, all right, what can we multiply times x squared to make x cubed? And that's going to be x. So we get x cubed plus x squared minus 2x. And now we want to subtract all of these. So we're going to change our signs. We get, those are gone, so we're left with negative 3x squared minus x. So now we're trying to, what do we multiply times x squared to make a negative 3x squared? So that's going to be minus 3. Just to keep my minus 3. So we have minus 3x squared minus 3x, and that's going to be plus 6. Okay, so now we need to change our signs. So that's going to be a plus, and this is going to be a minus. So that is gone. We end up with 2x minus 6. So this is going to be our remainder, but we don't need that. We are focusing on this quotient up here. All right, so for our quotient, we have x minus 3. So this is the equation we're going to use for our slant asymptote. And when we go to graph that, don't forget that when you graph a line, you're going to start with your y-intercept of this line right here, plot this point, and then use your slope to navigate. So my slope here is 1 over 1, so I'll go up 1 to the right 1. So we'll talk more about that on the next slide. All right, our x-intercept. X-intercept is where our y is equal to 0. So looking back at our equation up here at the top, that's going to be focusing on our numerator. So there are 3 places where our numerator could be 0, and that's when x is equal to 0, when x plus 1 is equal to 0, and when x minus 3 is equal to 0. So my x-intercepts are going to be 0, 0, and I can solve here to get negative 1. I have negative 1, 0, and 3, 0. So I have 3 x-intercepts. Now my y-intercept is where x is equal to 0. Well, we already know what that is. We have it right there. So our y-intercept is going to be also 0, 0. And if you want to double check that, you can plug 0 in up here, and you'll see that you're going to get 0 divided by -2, so you will indeed get 0. All right, so now let's sketch this. I've already copied over all of our important information. I have my vertical asymptotes. I have graphed my slant asymptote. You'll see that I started at -3 on my y-axis, and then I used my slope of up 1 over 1, up 1 over 1, up 1 over 1. So that's how I graph my slant asymptote. I've also put on my my x-intercepts. I think I left one off, didn't I? I left off -1 up here. Yeah, that's okay because we have it on our graph already. So we have -1, 0, we can tuck in there. And then I went ahead and just found some points that are kind of in between all those blue values that I've already found, just so I can get a kind of a shape of what my graph is going to look like. So what I did was I used my calculator. I used my table again. So if you take out your calculator, click on table, and option 2, edit function, enter in your equation. So we've got in our rational equation, and I'm just going to select the option where it says x equals question mark, and I'm going to calculate so I can populate my table. All right, so I want to find out the value of the value of y when x is equal to -3, and I get -9. And then I just went ahead and just picked values out of my domain just to kind of fill in, just to have an idea of where this graph is going. So at -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have a point way down here. And at, what do we have? -1.5. We are at 2.7, so we're somewhere up here. At -0.5, we're at -0.39, so somewhere right about here. At 0.5, I'm at 1.5, so I'm somewhere right about here. And then I have 1.5, I am at -3.2, so I'm somewhere right about there. And then at 1.5, I am at -1.5. So that was 1.5, 1, 2, 3. At 2, I am at 1, so somewhere right about there. And then at 4, I am at 1, I'm above the line. All right, so let's see if we can make sense of this. So let's start over here in the left-hand side. So we know that the way that asymptotes work, we know that horizontal asymptotes can be crossed, and slants can be crossed as well, because they're kind of fall in the same category as that horizontal. So we know that over here to the left, for my vertical asymptote, we know our graph should be going, getting super close to that asymptote. Now on the other side of it, we can just assume that it's hovering somewhere down there. If you want to find more points, you may do that. We're not going to require you to be that specific here. Now, in between these two, we did have to kind of plot a few points just to kind of see the behavior of what was going on. And we can kind of see now we have this almost like parabola looking figure on the inside. So we have this kind of shape. And then over here to the right-hand side, we can see that we're trending down, getting close to that vertical asymptote on the right-hand side of it. But then you notice that that other point is above. So, and just like horizontal asymptotes, their in behavior says that those y values are going to approach whatever that horizontal, in this case, our slant asymptote is going to be. So this is going to be the general shape of our rational function. Now, as we're learning and as you're practicing, I highly suggest you go over to Desmos and plug in your equation and just double check your sketch. We are going to be testing on this. You may not have one on your test that is this difficult, but there will be some others in the lab manual that we'll be able to work through together. So let's go over to Desmos. I've already have that entered in. If you want to see how I have that entered in, you may look at it right here. I have my function, my rational functions in blue, and all of my asymptotes are in red. And you can kind of see that we have basically the same shape. You can see how this blue line, the function is just on the right hand side is slightly above that asymptote, but as we zoom out, it's almost as if they have become the same line, but we know it's just hovering right above it. All right, good job.